All right, so I'm going to continue that exponential regression that we were looking at. And what I did first is I was just not quite remembering the format. So if you go to, I just thought, well, let's take a look before I say and do something wrong. But Desmos exponential regression, I'm just Googling that to make sure I type the format in there. Enter your data in the table like I showed you, and then down here you're going to do your y1 tilde ab to the x1 is what you want the regression formula to look like. So sorry about that. I just kind of blanked out on the format of that regression equation. So let's go back. I think it's on this tab. Okay, there's my temperatures. And then down here, my tilde here is, again, the Y1 has to match the title of this row or the heading of the column. And so the Y1, again, the formula A, B to the X1. So that 212 was bothering me when I started to write that. So my starting value, my B to the power of whatever the X is that corresponds to that Y. So my X sub 1 right there. And so then when we do that, here's your equation that you would end up with. You'd end up, according to the regression, if I didn't type things wrong, 92% correlation, not so bad. I mean, could be better, but 196.742 for your starting amount. Remember, ours was actually 212, but to make all of the rest of them come out as much as possible. And then your multiplier, this 0.969 is what would have for this problem. So let me see, I'm going to write that down. Equation again. If I've typed everything in correctly, let me double check my data so we didn't do something. 0, 2, 12, 2, 185, 3.5, 175, 162, 7.5, 145, 10, 138, 15, 125, and 20, 117. Okay, that data is all typed in right. And the equation, they're suggesting 196.742. I'm going to use all the decimals that I have to be as accurate as possible. 0.969073 to the power of X, just like it shows right there. All right, so let's go back to that page I was working on. And let me put this equation up here. So my exponential regression equation that came up from Desmos was the temp equals 190, oops, not a decimal, 196.742 times this 0.969073 to the power of, and these are like the minutes. Just double check what I wrote down for my data too to make sure I didn't copy anything wrong here. Yeah, I think my data was right that we typed in. All right. So now we come down to the next question where it says how many minutes would it be until it reaches 70 degrees? So 70 goes in for my temperature on that F. You could use the graphing feature to type this in and then just look for where it equals 70 on the graphing calculator of Desmos as well. Otherwise, the algebra to solve it here would be to divide by the 196.742. And after I do that, for example, on my calculator, probably even some more gross decimals here. Of 0.35579599155 equals now this 0.969073 to the power of m and whatever x, the number of minutes. And then again, this is once you get to the base and the power is the variable, that's where you can do a log. So that's where you go log base this is my base, right? Base and exponent. So this little subscript here, 0.969073, if I haven't messed that up yet anywhere. And then of this, 0.355795531, and that ends up equaling my exponent. Yeah, so on my graphing calculator, I can go I think I showed you how to do it in Desmos as well, but log alpha window, which is log base, and then you can type in those exact bases. I'm getting like 32.89. So remember, these were minutes. So if I went 32.89 over here, there's more decimals, obviously, but that would get me to the 70 degrees. Then what it says is, well, what would the temperature be after 45 minutes? Remember the 45 minutes, this 45 minutes right here, that's just plugging it in to the exponent. So I would put in here the minutes as 45. Well, 45 minutes, but these, oh yeah, these are all minutes. So the 45 minutes just gets plugged in and then crank. So I'm going to put that into the 196.742 times the base of the 0.969073 and raise that right here to my 45. Up there, raise to the power of 45 minutes, and I get 47.8563192. So degrees. But that makes sense, because remember, it's 212 down to here, it's 70, and then down to here. So there we go. I think we've answered all the questions for that problem. All right. Now I think that ends the lesson finally. That was a long one. All right. Thanks for watching.